Hi Bobcats, this is Miss Lee, and today's video lesson is writing 1 and 2-step linear equations from tables and graphs. Please make sure as we go through this video that you are taking good notes. Okay, so from a graph we can determine if the rate of change is positive or negative. Okay, so we talked about rate of change in our previous video when we were writing equations from tables. We said the rate of change, it is the coefficient to the x. It is that multiplier to x, the number that you're multiplying or you're dividing x by. And when you have a graph, just looking at the graph, you can tell if it's going to be a positive or a negative. So if you look at graph A, how is it going? It's going up, right? It's going to the right. It's starting down here and it's going to the right. So it's increasing as you move up to the right. So this is going to be a positive, and I'll just put a positive symbol, a positive rate of change. Look at B. How's this one going? Well, it's starting up here at 6, and you can see that as you move to the right, it is getting smaller and smaller. So this is going to be a negative rate of change. So I'm just going to put a negative symbol. What about for C? As you move to the right, you are increasing, so it is a positive. And what about for D? What happens as you're moving to the right? It is getting smaller, right? So it is a negative. So that's one way to tell if your rate of change is going to be a positive or a negative. You can also determine the y-intercept, and we talked about this when we were writing the equations from tables. We said the y-intercept, it's that constant value. It's the value that y equals when x is 0. It is where the line crosses the y-axis. So that's all you have to do. Where does it cross the y-axis? If you look right here, it crosses the y right here at 3. So the y-intercept, or B, would equal 3. Looking at our second example here, where does it cross the y? It crosses right here, halfway between 4 and 8, which is a 6. So your y-intercept 6, your y-intercept, or your constant, would be positive 6. Coming down here, this is graph D. It crosses right here, which is at a negative 3. So your y-intercept is negative 3. When x is 0, y is a negative 3. Those are your y-intercepts. So you can easily tell from a graph if your coefficient is going to be a positive or a negative, and what your constant is by determining where it crosses the y-axis. From a graph, you can also create a table of values to find your rate of change, and then write your equation in the form of y equals mx plus b. So let's try it. This example has kind of been done for us. First thing you want to do is look at your graph and identify 2 points. And you want to make it easy, guys. If you put a point right here, can you easily tell what that value is? Well, I know it's going to be a negative 8 for the x, but when I go up on the y, it's not 5 because it's not on the line. It's not exactly in the middle between 5 and 6, which would be even hard to tell if it was. So we don't really know the exact value, do we? That's going to make it hard to read. You want to look at the ones that are easy, where there's an intersection of the x and the y. It makes that intersection point. So looking through, they've showed us 2 points where they intersect, right? They intersect right here at 0, 5, and they also intersect at 8, negative 2. So put those into a table. Put in the x value, the y, put it as an order pair, 0, 5, 8, negative 2. So it looks like an order pair. Then from that, you can use that table to determine your rate of change, to determine your y-intercept, and to write your equation. So remember, our rate of change is going to be the change in y over the change in x. So using our table, the y goes from a 5 to a negative 2. It's decreasing, which means it's going to be negative, which makes sense because doesn't our line decrease as we move to the right? Okay, so how far did it change? Well, I know from 5 to 0 would be 5. And then from 0 to negative 2 would be 2 more. So it decreased by 7. So it's a negative 7. The change in y was a negative 7. Now, do the same thing for your x. What is your change? From 0 to 8. Well, that increased, didn't it? And it increased by 8, so it would be a positive 8. Put it together nice and neat, it's going to be a negative 7/8. That's going to be the m in your equation. Now, so this is our m. Now let's find our b. Let's find what does y equal when x is 0. So you could look at the table because it actually tells you that when x is 0, y is a 5. That's one way of looking at it. Or you could look at the graph. Where does the line hit the y? It hits or crosses the y at 5. Then write your equation. Y equals the rate of change, negative 7/8, times x. And then our y-intercept is a positive 5. Y equals negative 7/8 x plus 5. That would be your equation. Okay, so this is the last example. I want you, actually no, there's one more, so let's do this one together. Okay, same thing. We want to find some ordered pairs, some points that we can put into our table. So we want to find points where they actually cross at the intersection of the x and the y, like this point right here. And if I go down, there's really not any other ones until I get down here to the origin. So I'm going to start with the origin, 0, 0. And then my other point, the x is a 4, the y is a 30. Okay, step 1, we want to find that coefficient, that rate of change. We're going to find the change in y over the change in x. Use your table. How is the y changing? It's going from 0 to 30, so it's increasing by positive 30. Do the same thing for the x. From 0 to 4, it's increasing by a positive 4. Then you want to simplify. Divide by 2, and I get 15 halves. You are more than welcome to leave it improper. That is fine. There is nothing wrong with it as long as it's simplified. But some of you are like, no, we need to change it back to a mixed number. That is definitely fine as well. So do your TIBO, top and bottom out. 2 divides into 15 7 whole times, and it leaves you a 1 remainder. So 7 1/2. So either one of these are just fine. This is going to be the m in your equation. Remember, our equation is y equals mx plus b. This is your coefficient, your m. Now let's find the b. Where does it cross the y-axis? Well, when I look, my line hits the y-axis at 0 when x is 0. It crosses at 0. So the y-intercept is 0. You could also look up here at the table because it does tell us that when x is 0, y is also 0. Now put it all together. The y stays the same, equals the rate of change. I'm going to keep it improper. If you want to use the mixed number 7 1/2, that's fine. 15 halves, x. Now, our y-intercept is a 0. Do we really need to put plus 0? No, we don't need to put plus 0 because that doesn't really add a value to our equation, does it? I mean, yes, it tells us that the y-intercept is 0, but by not having the 0 here, doesn't it still tell you, oh, there's no 0, or there's no 0, or there's no y-intercept, so it's a 0, right? So really, you don't need this plus 0, just drop it off. This would be your equation, y equals 15 halves x, or y equals 7 1/2 x, or y equals 7.5 x if you want to change it to a decimal. Okay, last example. Pause the video, do this one on your own. Find you 2 points, put them in your table. From there, find your rate of change, that change in y over change in x, and then find your y-intercept and write your equation. Once you're done, come back to check to see how you did. Okay, did you get that your equation is y equals a negative 2x plus 3? If you did, awesome job. If not, let's go through it really quickly. First of all, you know that your coefficient, your rate of change, is going to be negative because as your graph moves, as your line on your graph moves to the right, it's decreasing, isn't it? Okay, so here we go. First thing we want to do, find your rate of change, the change in y over change in x. So we have to come up with a couple of points. There are actually several points on here that you could have chosen. I just went with the first two up here, the negative 2, 7, and the 0, 3. So using those, my change in y was 7, was decreasing, and the difference between 7 and 3 was 4, so it was a negative 4. My change in x was increasing, going from a -2 to a 0, so it increased by 2. So -4 over 2 simplifies to -2. That is your m in your equation, your coefficient. Then your y-intercept. Where does the line cross the y? It crosses the y-axis at 3, or you could have used the table because I had a point when x was 0, y was 3. So either one, that's your y-intercept, that's your b, it's a 3. Put it all together, you get y equals a -2x plus 3. Now, if you're really confused and you're like, you know what, I don't know if I wrote the right equation or not, then guess what? You can try it out. Okay, pick a value. I'm going to pick -2 for x, and I'm going to replace x with a -2. So y equals a -2 times x, which I'm using a -2 for my table, plus 3. Order of operations says I multiply first. -2 times -2 is a +4. And what is +4 plus +3? It is 7. Is that what y equals? Yes. So we got the correct answer and the correct equation. Okay, great job, Bobcats.